Welcome to Algebra 2, Unit 5, Lesson 9 practice problems. In these practice problems, we are going to concentrate on the horizontal scaling of functions. Here are graphs of functions f and g. For each, determine the value of k so that g of x equals f of k times x. So in the top left example here, f of x is the dashed line, and g of x is the solid line. Now the function values are the y values. So in this one, we want y, which is 0 on f of x, to equal y, which is 0 on g of x. So these 2 points that they have labeled are the corresponding points. So if we look, when y is 0 for g, x is 30. So we're saying g of 30. Now, that means we have f of k times 30. So now we need to know, what does k have to be in order for 30 to become 10? So we have k times 30 equals 10. If we divide both sides by 30, we find our answer, which is that k equals 1/3. So now we could write the new equation, which would be g of 30, or g of any x, equals f of 1/3 x. Now we can look at the top right. In this one, g of x is the dashed line, and f of x is the solid line. So now the 2 corresponding points each have the value of 0 for y. So we're saying g of 5 equals f of k times 5. And we see that the f value is 3.125. So we need k times 5 to equal 3.125. For this to happen, we're going to divide both sides by 5. And we will get our answer that k equals 3.125 divided by 5 equals 0.625. So that means g of x equals f of 0.625 x. Now if we look at the bottom left example, g of x is the solid line, and f of x is the dashed line. So in this one, we have corresponding values where g of x, the x value, g of 0.277 needs to equal f of k times 0.277. So we have k 0.277 equals the f value, which is 0.693. So now we can divide both sides by 0.277, and we find our answer, k equals, if we take 0.693 divided by 0.277, we get 2.5. So we would write g of x equals f of 2.5x. As we look at the bottom right example, we see that g of x is the solid line and f of x is the dashed line. So we're saying that g, with an x value of -8, needs to equal f of k times -8. So here we're saying that k times -8 needs to equal +4. So to get k by itself, we would divide both sides by -8, and we would get our answer that k equals -1/2. So when we write this, we would say that g of -8 equals f of -1/2 times x. And if you notice, we've got the 1/2 scaling, which is its horizontal scaling, and the negative in front of the x, which would flip it or reflect it over the y-axis. And this would have been the same if we had chosen to use the bottom 2 points, just as when we used the top 2 points. If you have any questions about how I worked these practice problems, please use this time now to ask for clarification. Let f of x equal x times x minus 5 times x plus 2 times x plus 5. Decide if the reasoning about each of the following functions is correct. Explain your reasoning. Number 1. Andre says that g of x equals 0.1x times 0.1x minus 5 times 0.1x plus 2 times 0.1x plus 5 is obtained from f by scaling the inputs by a factor of 0.1. In this case, we are trying to scale the inputs, and inputs are the x values. So if you notice, we multiply the x by 0.1 in every situation. So number 1 is true because x has been replaced by the scaling factor (0.1x). Number 2. Claire says this graph is a vertical shift of the graph of f down 100 units. Well, one thing we know is that if x equals 0, then that means the y-intercept is at the origin. Because if we replace the first x with 0, 0 times anything becomes 0, which times anything becomes 0, and times anything becomes 0. So, at the origin, or at x equals 0, the y-intercept would originally be at the origin. That means this graph was actually shifted up 100, not down 100. So we would say the original y-intercept was at the origin so this graph shifted up 100 units, not down. And number 3, Diego says the graph of k of x equals negative x times x minus 5 times x plus 2 times x plus 5 is the reflection of the graph of f over the y-axis. So a reflection of the graph over the y-axis means that we flip it sideways. Therefore, we are changing the x value to the opposite. But when we look at this, the only negative is in front of everything. We did not replace x with negative x in each instance. So this actually changes the value of the y, which means it was reflected over the x-axis. So we would say the one negative symbol changes the y value so it's reflected over the x-axis. If you have any questions about how I answered this practice problem, please use this time now to ask for clarification. A bacteria population in thousands is modeled by the function f of d equals 30 times 2 to the power of d, where d is the number of days since it was first measured. The function g gives the bacteria population in thousands w weeks after it was first measured. Express g in terms of f. Explain your reasoning. So there are two ways that we could express this. First, we now have g of w, and we can either say that the original equation, 30 times 2 to the power of d, there are 7 days in a week. So we can change d to 7. Then we can put this factor and exponent in parentheses, and we can raise that to our new input, w, which is the number of weeks. The second way we can write this is as a horizontal scaling factor. So we could say g of w equals f of 7w, because however many weeks we have as the input, we would need to multiply it by 7 in order to turn it into days, which is what f is represented in. If you have any questions about how I answered this practice problem, please use this time now to ask for further clarification. The population of sloths in an area has been increasing by 5% each year since 2000. Let P model the population, P of T, in thousands of sloths T years after the year 2000. The graph of P of T equals 1.05 to the power of T has a general shape that fits the data. Find a scale factor k so that P of T equals k times P of T fits the data. So what we can do is substitute in what we know and then find k. So P of T, capital P of T, is the population. And that is going to come from this right-hand column. Lowercase p of t is going to come from the 1.05 to the power of t. So what we can do is on this first row, we can substitute 15.7 in for capital P of t, equals k times p of t, which we said was 1.05 t. And in this case, t is going to be 5. So now if I want k by itself, I need to divide both sides by 1.05 to the 5th power. And now I have k equals 15.7 divided by 1.05 to the 5th power. Now if I put this into a calculator, 15.7 divided by, I'm going to use parentheses so that I can keep this bottom part together, 1.05 to the power of 5. And then close my parentheses and hit equal. And we get an answer of k equals approximately 12.3. If we wanted to try another one to double check this, we could use the bottom row here, or the second row here. So now we're going to say k equals, instead of 15.7, we're going to go down a row, and we're going to use 18.2. And that is going to be divided by 1.05, and this time our input is 8 instead of 5. So now we'll put this in the calculator, 18.2 divided by 1.05 to the power, oops, let me retype that, 18.2 divided by parentheses 1.05 to the power of 8. Close parentheses and hit equal. And if you notice, our answer again is approximately 12.3. So now we can see that our scale factor k equals 12.3. So if we wrote this, we could say capital P of t equals 12.3 times lowercase p of t. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Here is the graph of a function f. Reflecting f across the x-axis and then across the vertical line y equals 1 takes the graph of f back to itself. Tyler says that this means f is an odd function. Do you agree with Tyler? Explain your reasoning. So, Tyler is saying this is an odd function. An odd function is symmetrical about the origin. You need to be able to reflect it across the x-axis and across the y-axis, not across the vertical line y equals 1. So, no, I do not agree with Tyler because an odd function must be symmetrical about the origin. It must reflect across both axes. Not the vertical line at y equals 1. If you have any questions about how I solved this practice problem, please use classroom time now to ask for further clarification. The height of a hot air balloon in feet m minutes after takeoff is modeled by the function f of m equals 16m. Number 1. How many minutes does it take for the balloon to reach 200 feet? To answer this, if it gives us the height in feet, then we can substitute 200 in for f of m, and now we can solve for m. The first thing we're going to do is divide both sides by 16. So now we have 200 divided by 16 equals m, and that's 12 and a half minutes. So it takes 12.5 minutes. Number 2. Another balloon takes off 5 minutes later and rises at the same speed. Write an equation for the function g, where g of t is the height in feet of this balloon in terms of m. Explain your reasoning. So if this balloon takes off 5 minutes later, then we are shifting the graph 5 units to the right. If we shift 5 units to the right, then we subtract 5 from x. So if we wrote this, we would say g of m equals 16 times m minus 5. So all we've done here is instead of m, we've replaced m with m minus 5 because m minus 5 shifts 5 units right. Number 3, wants us to sketch graphs of the two functions, f and g. So for f, we know that it's going to start at the origin, no minutes, no height. We know that after 12.5 minutes, which is halfway between 10 and 15, it will reach its height of 200. And now we can draw the line connecting them. And this would be f of m. Now for g, we said the only change is that it launches 5 minutes later. So now this one starts at 5 minutes, 0 feet of height, and instead of 12.5 minutes, it would be 17.5 minutes when it reaches its height of 200 feet. And now we can draw the point, or the line connecting the points. And this would be g of m. If you have any questions about how I solved any of the practice problems on these worksheets, please use class time now to ask for further clarification before we move on to the next lesson on Thursday.